Hi, fifth graders, and welcome to your next virtual learning math lesson. I hope everyone is staying healthy and getting outside a little bit while social distancing to get some fresh air. It's very important that you get some sunlight and fresh air every day, even if it's just a little bit. Let's get ready to learn. Make sure you find a quiet place to work, have out a pencil and your math notebook, and message your teacher if you need any help. Let's recall what we learned in our last video. In our last video, we reviewed how to simplify fractions. That was our warm-up. In our last video, we learned how to multiply fractions and whole numbers together. And in our last video, we multiplied fractions by fractions. We're going to need all of those skills today as we learn our next lesson. Let's do a little warm-up first. There are two different skills we're going to practice in our warm-up today. For numbers 1 and 2, you're writing each mixed number as an improper fraction. And then for numbers 3 and 4, you're writing each improper fraction as a mixed number. Go ahead and pause the video, work on these 4 problems, and when you're finished, hit play and we'll go over the answers. All right, welcome back. For number 1, we're writing the mixed number 3 1/2 as an improper fraction. For number 1, I'm going to show you a model of this problem. So here's a model that's representing 3 wholes, 1, 2, 3, and then half of another whole. To think of this as an improper fraction, which is a fraction whose top number or numerator is greater than its denominator or bottom number, we need to split it up a little bit. So what I'm going to do, since my denominator is a 2, and we can see that this fraction is already cut up into 2 equal parts, we're going to go ahead and do that for all of these wholes. So I'm going to cut all of these in halves. Now, to find out how many halves there are, let's count. We have 1, 2, 3, 4, 5, 6, 7. So we have 7 halves. Ooh, that's an ugly 2. Okay, so 3 1/2 is the same thing, equal or equivalent to 7 halves. All right, let's do number 2, but I'm going to do this without a model and show you how you can do this with just the steps. So we're taking 6 1/7 and we're writing it as an improper fraction. All right, oopsie. So let's take 6 1/7 and make it improper. Of course, you could draw this model just like we did for number 1. If that helps you to understand the problem a little better, please feel free to do that. Otherwise, I'm going to show you how to do it without a model. We take our denominator, 7, and we multiply it by our whole number, 6. Think about it. 7 times 6, yep, it's 42. Then we add the numerator to that product. So we take the 42 that we got, we add 1, yep, we get 43. That becomes our new numerator, 43. And we keep the same denominator, so that 7 goes over here and is our denominator. So 6 1/7 is equal or equivalent to 43/7. If you drew a model, you should see that in your rectangles that are cut up into 7 equal pieces, there would be a total of 43 pieces that were cut up into 7ths. And that's what that means. All right, let's go over the opposite of that. What happens when you're given an improper fraction and you need to turn it into a mixed number? Students sometimes tend to struggle here a little bit more, but that's okay, we'll get through it. All right, so now let's write 13/4 as a mixed number. I've made a model for 13/4. What I've done is I've cut a large rectangle into 4 equal pieces because my denominator is 4. And then I need to shade 13 of those pieces. Well, if you only make one large rectangle, you don't have enough pieces. You only have 4 pieces, which means you have to keep making these long rectangles until you get 13 that you can shade in. So here I have 1, 2, 3, 4 fourths, 5, 6, 7, 8 fourths, 9, 10, 11, 12 fourths, and I need to do another one to make 13 fourths. To write this as a mixed number, I need to count all my holes. I have 1 hole, another hole, a third hole, and then I have some leftover parts. So as a mixed number, I would write this as 3 holes, and then I have 1/4 left over. So 13/4 is the same thing as 3 1/4. And you could also check this using that circling method that we just did. So you could take your denominator 4 times your whole number 3. 4 times 3 is 12. Plus 1 is 13. Keep your denominator 4, and you can see that we get 13/4. All right, I would like to show you how to do this without a model. Now, like I said before, if you want to continue using models, there is nothing wrong with that. It can be very helpful to understand the skill, and then eventually you won't need models anymore. Let's take a look at 23/8. This is really just a division problem. If you remember from previous chapters, fractions are division problems. So this is the same thing as saying 23 divided by 8. So you could do this as a long division problem. How many 8s can you pull from 23? Well, you can't take 8 out of 2, so you have to look at 23. 8 can come out of 23. Let's think of our 8 times tables. 8, 16, 24. That won't work. 24 is too high. So we can pull 2 whole groups of 8. And now you can see where it's starting to sound like a fraction and a mixed number, because we can pull out 2 whole groups. And then what's left over? Well, 2 times 8 gives us 16. So when we pull those 2 whole groups of 8 from 23, what's left over? Well, to get from 16 to 20 is 4, and then 3 more. 4 plus 3 is 7. So that's me using my mental math to get 23 minus 16. And I get 7. So that 7, we're not going to write remainder because we're looking for a mixed number. 7 becomes our numerator, and then 8 is still our divisor. So 23/8 is 2 and 7/8. Okay, and there you have it. Like I said earlier, you're going to have to be able to use both of these skills from the warm-up today. So if you need to rewind and watch this, do that as many times as you need. Don't give up, and don't just say, I can't do this. Rewind, watch it again, ask your teacher for more support. All right, today's objective. Here we are getting into the lesson. I will be able to multiply mixed numbers. See why we were working with mixed numbers in the warm-up? I just have some notes. If you'd like to copy these down, you can pause the video, copy them down, or you can just stay with me. This star is very important. It says to multiply mixed numbers together, you must first rewrite them as improper fractions. And so many times students will ask me, do I have to? It's more work. Do I have to write them as improper fractions? Yes, you have to. What's that, Vinny? Do you have to rewrite them as improper fractions? Yes, you have to. Just kidding. He doesn't even know what I'm talking about. He's only 3 1/2. But anyway, let's look at an example. If we have 3 1/3 times 1 1/2, we cannot just multiply numerators, multiply denominators, and multiply the whole numbers. It doesn't work that way because multiplying mixed numbers follows the same rule as multiplying fractions. And 3 1/3 is not a fraction until you make it one. So let's make it one. If you can remember how to do this, we take our denominator 3 times our whole number 3. Yep, it's 9. And then add in your numerator. 9 plus 1 is 10. And 10 becomes our new numerator. And we keep the same denominator. So 3 1/3, if you wanted to draw a model, it would look like 10 thirds. Now we do the same for our other mixed number. Denominator 2 times whole number 1. 2 times 1 is 2, plus 1 is 3. That's our numerator. And then keep your denominator. So 1 1/2 is the same thing as 3 halves. Well, now we can multiply the fractions. That was what we did in our previous lesson, and simplify it if we need to. So we have 10 thirds times 3 halves. So let's multiply this out. Now, I showed you in our other lesson how you can simplify the problem. I'll show you both ways. One way to do this is to just multiply our numerators. 10 times 3 is 30. And then multiply our denominators. 3 times 2 is 6. Ooh, that's ugly. There we go. And simplify. 36 are the same as 30 divided by 6. And 30 divided by 6 is 5. So our answer is 5 when it's in simplest form. Now I'm going to show you another way to get 5. When I look at my problem, 10 thirds times 3 halves, and I look diagonally, I see that diagonally I have a pair of 3's. That means they can simplify. What does 3 and 3 have in common as a factor? Well, 3. So we can turn them both into 1. Whenever your diagonal is the same number, you can just scratch them out and make them 1's. So those 3's disappear. In fact, I'll erase them to show you that they have now turned into 1. Check your other diagonal. 10 and 2. Is there a number I can divide 10 and 2 by? Yep, I can divide 10 and 2 both by 2. So what's 10 divided by 2? 5. And what's 2 divided by 2? 1. So I'll erase that so that you can see that my new numerator here is a 5 and my new denominator here is a 1. I simplified my problem here. And now with all these 1's, that's beautiful. 5 times 1 is 5. 1 times 1 is 1. 5 divided by 1 is still 5. So you can pick which method you like to use. You don't have to do the second way, but it can be helpful for some people. All right, so now let's look at some of the examples that were in our book. Whoa. All right. A blueberry muffin recipe calls for 1/2 cup of blueberries. A blueberry pie recipe calls for 3.5 times more blueberries. How many cups of blueberries are needed to make the pie? I want to point something out before we move on. A very common mistake for students when they see a word problem is to look for numbers and do something easy with them, whether that's adding them, multiplying them, whatever. If you don't understand what the numbers represent, you could very easily get this wrong. A lot of people are thinking, hey, we're multiplying in this lesson, so let me take this and multiply. But why? Why is it multiplication? Well, let's take a look. One recipe, okay, the muffin recipe, needs 1/2 cup of blueberries. Okay, so picture 1/2 cup. Now the pie recipe calls for 3.5 times more than that. So it's not calling for 3.5 cups. it's calling for 3.5 times the other amount. So we're taking this half cup and we're multiplying it 3.5 times. So we're taking 3.5 times a half. One way to do this is with a model. To be honest, I'm not particularly fond of models for multiplication with fractions and mixed numbers. I think it can be more confusing than it can be helpful. So I'll just zip through the model, but then show you how to really do it. The model shows 1/2 because if you look vertically, up and down, there are 2 rows, okay? And we're pointing to one of those. So 1/2 is right here. And then going horizontally or across, we're seeing 3.5. Now here's where it can get a little goofy. 3.5 is, if you can tell, this is a little bit of a darker, thicker line. So 3.5 is coming from, this is 1, this is 2, this is 3, and then here's a half. And that's where that 3.5 is coming from. All right, so if we shade where they meet up, and let's see how well I can do with some shading. We'll do green, make this a little thicker. All right, so we have 1/2 is going this way, and 3.5 is going this way. So let's see how many pieces that is. We have 1, 2, 3, 4, 5, 6. My shading skills are not that great. And 7 pieces right there. Now, why did I not shade anything up top? Because that was not part of my 1/2. My 1/2 was down here. Why didn't I shade right here? Because that is not part of my 3.5. So how many squares did we shade? We counted 7. All right, let's go down. The shaded squares can be rearranged to form part of the model to the right. So if I take these 7 squares and I try to make them an array, okay, I can now see that I have 7/4. And again, where are they getting this 4th from? Because if I draw a line, oops, right here, okay, now I have 2 groups of 4s. I have 1, 2, 3, 4, 5, 6, 7 groups of 4, or so not 7 groups of 4. I have 7 pieces of the 4ths. So how do we take that 7/4, that improper fraction, into, let me get this smaller, into an improper fraction? We go 7, and then 4ths. So what does that look like as a mixed number? Well, 1 whole group of 4s was shaded right here. There's my whole. And then 3/4 was left. And that gives you my 7/4. So as a mixed number, we say there's 1 whole and 3/4. Now, like I said, I do not find the models that helpful. Okay, I think that this step here can get a little confusing. Maybe you like it and maybe you think it's awesome, and that is super. So how would we do this without the model? I'm going to show you in this little bit of blank space here. So I'm going to take my original problem, which was 1/2 times, I forget, let me go up, times 3.5. And if you remember back to the notes page, all mixed numbers have to be turned into improper fractions. So I need to do that little circle-y thing with 3.5. 2 times 3 is 6. 6 plus 1 is 7. So I could rewrite this as 1/2 times 7, keep your denominator, halves. And now I multiply my numerators, multiply my denominators. 1 times 7 is 7. 2 times 2 is 4. Notice we get the same thing that we had here, but we have to still turn it into a mixed number. All right, let's take a look at another example. Find the unknown in 1 1/2 times 3 3/4. I'm not going to do the model for this one. I'm just going to walk you through the steps. The model is to the right here if you'd like to pause and take a look at it. We have 1 1/2 times 3 3/4. Well, we need to make them fractions. They are mixed numbers. We don't want mixed numbers. So let's start with 1 1/2. If we do that little circly thing to make it improper, 2 times 1 is 2, plus 1 is 3. So my new numerator is 3, and I keep that same denominator, 2. Now let's look at the second mixed number, 3 3/4. 4 times 3 is 12, and 12 plus 3 is 15. Keep your same denominator, 4. So we have 3/2 times 15/4. Remember, to multiply fractions, you go straight across. 3 times 15. Very good, 45. And 2 times 4, yep, that's 8. 45/8. Remember from your warm-up, how do we make 45/8 into a mixed number? You could either use a model or you can think of division. How many 8s can you pull out of 45? I'm going to count by 8s on my fingers. 8, 16, 24, 32, 40, 48. Nope, 48's too high. So I can pull out 5 groups of 8. That becomes my whole number. Ooh, that's ugly. Looks like a silly S. There we go. So I could pull out 5 groups of 8. Well, when I pulled out 5 8s, how much was that? Yeah, 5 8s are 40. So what's the difference between the 45 that we had and the 40 that we needed? 5. 45 minus 40 is 5. Keep your denominator. So we get 5 and 5/8. So 1 1/2 times 3 3/4 is 5 and 5/8. All right, almost done. Let's take a look at the guided practice at the bottom. Find 4 1/5 times 1/2. Of course, we always write it in simplest form. They've done some of the work for you. Really, all you're doing is simplifying your answer. So pause the video, take a moment, look at the steps that they did right here, understand them if you can, and then get your answer in simplest form. Hit play when you're ready. All right, let's see how you did. So the first thing is to change 4 1/5 to an improper fraction. How did they get 21/5? 5 times 4 is 20, plus 1 is 21. So those guys go together. And then we're timesing it by a half. A half is already a fraction. There's nothing to do there. Multiply your numerators. 21 times 1 is 21. 5 times 2 is 10. Simplify. How many 10s can you pull out of 21? 10, 20, 30 is too high. So you can pull out 2 groups of 10. 2 groups of 10 is 20. So what's left? 21 minus that 20 leaves you with 1, 10. I keep my denominator. So 4 1/5 times a half is 2 and 1 10. All right, so if you are confused on this, I would go back, rewind it, watch it a second, third time if you need to. Ask your teacher for help if you need support. You can always go on YouTube, type in this skill, and you'll be amazed at how many different people have taught this skill and put it on YouTube. So that's always an option. If you would like to continue practicing, I'm going to display some more problems for you to work on. And what you can do is pause the video, copy them down, and then hit play and I'll show you some more. All right, here are some more if you wanted to try the models out. And then lastly, I have some problem solving for you to look at if you would like to try them. Always a good idea to get some practice with problem solving. You can pause the video, read the question, answer it on your paper. All right, and here we go with the last few. All right, I hope you enjoyed today's lesson on multiplying mixed numbers. Again, rewatch the video if you need to, ask your teacher for help, and I will see you again for the next lesson. Have a great day and stay healthy.